Principle of pumping scheme. As discussed earlier, the process of supplying energy to a laser system by external means to excite the atom to the required higher energy levels and thereby achieving population inversion is called pumping. Even though the atoms have a large number of energy levels, only 3 or 4 levels are involved in pumping process. In the upcoming slides, we will see the 3-level and 4-level pumping schemes. 3-level pumping schemes. In a 3-level laser, 3 energy levels are involved in pumping scheme, namely a ground level, the ground level, metastable state and the higher energy levels as shown in the figure. 3-level pumping schemes. In a 3-level laser, 3 energy levels are involved in the pumping scheme, namely ground state, metastable state and the excited state. During the pumping process, initially the atoms excited into the higher energy level E3, in which they cannot stay for a long time. Then they move to the metastable level E2 through a non-radiative transitions. In the metastable state, they can stay a relatively longer time as the spontaneous emission from the level E2 to E1 is forbidden. Therefore, a pumping process continues further. At one stage, more electrons are accumulated in the metastable state E2. Thus, the population inversion is achieved between E1 and E2. An incident photon interacts with the laser system can trigger the stimulated emission and thereby results in laser action. 4-level pumping schemes. A typical 4-level pumping scheme is shown in this figure. The level E1 is the ground state, E4 is the pumping level, E3 is the metastable upper lasing level and E2 is the lower lasing level. When light of pump frequency h nu is incident on the lasing medium, the active centers are readily excited from the ground level to the pumping level of E4. The atom stays in the E4 for only about 10 in power 8 seconds and quickly drop down to the metastable level of E3. As spontaneous transition from the level E3 to E2 cannot take place, the atoms get trapped at the level of E3. Due to further absorption, the population at the level E3 grows rapidly. The level E2 is well above the ground level, that is E2 minus E1 is greater than kT. Therefore, at normal temperature, atoms cannot jump to the level E2 from E1 on the strength of thermal energy. As a result, the level E2 is virtually empty. Therefore, population inversion is achieved between E3 and E2. A spontaneous emission of a photon of energy h nu is equal to E3 minus E2 can start a chain of stimulated emission, bringing the atoms to the energy level of E2. From the level E2, the atoms subsequently undergo non-irradiative transition to the ground level E1 and will be once again available for excitation.